Let's consider the derivative of each of these expressions. The derivative of x squared is 2x. The derivative of x squared plus 1 is 2x. The derivative of x squared plus 3 is 2x, etc. Because when we differentiate this constant, the plus 1, 3, take 3 or take 7, this differentiates to 0. So the derivative of x squared plus or minus any constant is 2x. So generalising this, the derivative of x squared plus c, where c is a constant, is always 2x. And the antiderivative of 2x is x squared plus an unknown constant. We use this symbol for antiderivative, but the correct name for it is an integral. So the terms antidifferentiation and integration are interchangeable. They mean the same thing. It's the reverse of differentiation. So the integral of 2x is x squared plus c. And given further information, we may be able to determine the value of c. So if the derivative of a function is given in the form ax to the power of n, then the function is ax to the n plus 1 over n plus 1 plus c, that unknown constant. So it's like we're raising the power by 1 and dividing by the new power. So if we think before, our derivative was 2x, which is like 2x to the power of 1, then the function is 2x to the n plus 1, which is now 2, divided by 2, which simplifies, the 2's cancel, to x squared, and remember always to write the plus c, because there could be an unknown constant which differentiated to 0. So that's thinking of it in terms of an antiderivative, where we have the derivative of the function and we're writing the function. Alternatively, we could just say the integral of ax to the n is ax to the n plus 1 over n plus 1 plus c. And because of this constant of integration, as it's called, this is known as indefinite integration. Try pausing the video and working through these examples before you watch my solutions. I'm going to use the integral notation. So the integral of x to the power of 4, and it's important to write the dx, which means with respect to x. So the integral of x to the power of 4 with respect to x is x to the power of 5 over 5 plus c. In the second example, the integral of 6x cubed with respect to x is 6x to the power of 4 divided by 4 plus c, and I can simplify that to 3x to the power of 4 over 2 plus c. The integral of 7 with respect to x, I'll write that as 7x to the power of 0 with respect to x. So raise the power by 1, 7x to the power of 1, and divide by the new power, which simplifies to 7x plus c. And finally, this is the integral of 8x plus x to the power of a half with respect to x, 8x squared over 2 plus x to the power of 3 over 2 over 3 over 2, which is 4x squared plus 2 square root of x cubed over 3, and don't forget the plus c. In that last example, we were integrating the sum of two expressions involving x, and it's worth pointing out that to integrate the whole expression is the same as integrating the two terms separately and adding them together. So if I integrate 8x with respect to x, I get 4x squared plus a constant of integration we'll call c1. And if I integrate the square root of x with respect to x, I get 2 square root x cubed over 3 plus a constant of integration. So if I simply define c as the sum of these two unknowns, then you should be able to see that the result is exactly the same. Similarly, when multiplying by a constant, it doesn't matter if you integrate the whole term or if you first integrate without the coefficient and then multiply by that coefficient. So the integral of 6x cubed with respect to x, remember that was 6x to the power of 4 over 4 plus c, which is 3x to the power of 4 over 2 plus c. Now if I just integrated x cubed with respect to x and then multiplied by 6, that would be 6 lots of x to the power of 4 over 4, which is exactly the same as 6x to the power of 4 over 4. So it can still be simplified to 3x to the power of 4 over 2 plus c. So generalising, integrating the sum of two functions of x is the same as integrating the two functions separately and adding them together, and integrating a multiple of a function of x is the same as integrating the function of x and multiplying by the same factor. One final example which will enable us to find the value of c and then go on to solve a further problem. So in this example we're given the derivative of a function of x. Firstly, we want to find y in terms of x, which means we need to antidifferentiate. Y is going to be the antiderivative of 4x take 2x to the negative 2 with respect to x. This is 4x squared over 2, which is 2x squared. And then remember we're raising the power by 1, so x to the power of negative 1 over negative 1. Don't forget the plus c. We'll just simplify that. 2x squared plus 2 over x plus c. Now the extra bit of information we're given here is that when x is negative 1, y is 2. This will enable us to find c. So if we substitute in these values, 2 is equal to 2 take 2 plus c means that c is equal to 2. So y in terms of x is y is 2x squared plus 2 over x plus 2. And then we can find the value of y when x is 0.5 by substituting in x equals 0.5. So y is equal to 2, 0.5 squared plus 2 over 0.5 plus 2, which is 6.5.